Okay, ladies and gentlemen, let's talk about end behavior. Now, end behavior on a graph is very, very simple because it happens at the ends. So if I were to take my hand and cover up the middle of this graph, I don't care what happens underneath this hand. I only care what happens out here or out here. Those are the only two places I actually care. So let's draw a graph. Now, that graph could look like this. Now, this is totally a function, a very nice graph, but I don't care about that part there. I only care about this and about that. So, in this case, as x is going out to positive infinity, y is going up to positive infinity. Okay? Now, over here, as x goes to negative infinity, y also goes to negative infinity. So as x goes to negative infinity, y goes to negative infinity. And I don't care what happens in here, even if this totally does that. I don't care because end behavior only happens at the ends. Now, we need to write this in a specific way because clearly this isn't a good mathy way to write this. So we're going to write it just like a point. A point would be something, comma, something. Well, how would I write that something, comma, something? Well, it's going to positive infinity and positive infinity, but the problem is I can't write a point with infinities in it. That doesn't make any sense. I can't get to infinity. So what I'm going to do is I'm going to say as x, arrow means approaches, positive infinity, y also approaches positive infinity. And that is my right end behavior. Now let's go over here. This one is going this way and that way. So again, as x goes to negative infinity. Now some people get confused. They want to put the negative infinity over here. Well, because it's going that way. It's not the way it works. We read from left to right. So we still write it like this. Now y is also going to be going to negative infinity. So there you go. But now, just because they happen to match here doesn't mean they're always going to match. Let's take a look at this. Here's another fine graph. Now, in this case, we could still say as x goes to infinity or positive infinity, y goes to positive infinity. But if I go this way, as x goes to negative infinity, going that way, where's y going? Well, it's going up. So y goes to positive infinity because remember, this graph can go any one of a couple different ways. This graph could be could be going this way, could be going this way, or it actually could be going somewhere in the middle. So as x goes to positive infinity, it could be going y positive infinity, y equals some number, or y equals negative infinity. I don't know which one of these it is unless I look at the graph itself. Same thing happens over here. I could be going positive infinity or negative infinity or somewhere else. So you have to list end behavior as x approaches something and y as it approaches something else. Just like a point, there are two parts. So we want to make sure that we're listing those separately. So in x, you'll always have one that lists positive infinity because it's going to go that way, and one that is negative infinity because it's always going to go that way. It's the y's that you're going to have to figure out. Does this go up, middle, or bottom? Up, middle, or bottom? And you'll have to figure it out from there. Now, to give you one more piece of the puzzle, let's do one more graph. And let's bring this in like this. 1, 2, 3, 1, 2, 3. Okay. So this looks somewhere around positive 3. This looks negative 3. In this case, again, I don't care what happens in the middle. I know that as x goes to positive infinity, y goes to... Now, in this case, it's not going up forever. It's not going down forever. It's going here somewhere in the middle. Well, where is that? Maybe you could argue, oh, it's going to negative 3, or maybe it's negative 2.8. I don't know from my graph. I'm going to call it negative 3. And that's one piece of the end behavior, but that's not enough because that's only one end. I got to go do this other end. So as x goes to negative infinity, where is y going? Well, that looks to be maybe somewhere around positive 3. So every graph has two ends. Every graph is going to have two pieces at each end, an x part and a y part. So given that information, you can use that wisely for your end behavior.